is part 2 of chain rule partial differentiation, and that it will talk about slightly harder type of questions that the chain rule partial differentiation will have. If you are keen to look at the easier type, then click the link over here. Okay, so now if you are the one who comes from the previous video, then welcome back. And therefore, let's continue with the next question that is something a little different. Ding. This question asks you to find the rate of S increasing when R is equals 3, H is equals 4, if R and H are each increasing at a rate of 0.25 cm per second. And the equation is given below. And this equation, if you search for the equation of a cone, you have the exact same thing, right? This is a cone. Alright, so this equation describes the cone, surface area of the cone. Alright, and therefore to first start, you don't even know this is a chain rule, right? Nobody tells you that this is a chain rule. But as you can see, it is increasing at a rate. You know that it's in terms of time. And therefore what you gonna do is to go and find how many variables are there. Alright, so it's to find how many variables are there, meaning from here we can see that there is R and H, so there are two variables, excluding the pi, because pi is just some number 3.18, 3.412, is it? 3.412 I think. Anyway, so find how many variables are there. So in this case we know that there is R and H, and therefore we would have two terms of the partial differentiation chain rule. Alright, so we'll have partial S, partial T, because we're going to change in time, right? The rate where in terms of second, right? So you have partial S differentiate in terms of R first, times partial R in terms of T, alright, plus partial S differentiate in terms of H, and then partial H over T. Alright, so this is the standard. Every time is plus. If it have more variable, then you plus another few variables, and so forth, and so on, and so on, and so forth, and yeah. Anyway, so what we're gonna do now is to same thing, write down the steps. So to write down the terms, write down partial, I think different color a bit better. So I just write down partial S, partial R, partial T, and then I have partial S, partial H, and partial R, partial H, partial T. Okay, so we're gonna differentiate in terms of partial S in terms of R, so we're gonna differentiate this whole time in terms of R. So this will test your differentiation skill, and then so I would assume that you are a very professional person in doing differentiation, so I'm not gonna do the differentiation part. Ta-da! No lah, just do it out. Okay. So if indeed you are really professional, then I'll suggest you just skip to the later part to see what are the rationale behind solving this. But if you are somewhat a bit unstable, then let us do together, you know. So partial S, partial R. If I differentiate R over here, I would have R, what the hell, 2 pi R plus, so you see that there is one R over here and there's another R over here inside. So this is in terms of a product rule, right? So if one variables is also, like, you know, multiplied with another variables inside, then you know that you're not gonna use product rule, product rule. Otherwise you can just implant inside, but I will not suggest it. So what we can do is to use product rule. So I differentiate the outside first. So I have pi, I keep this, right? So I would have, instead of writing the square root, I'll just write in terms of half, right? So square root a is equals to like that, alright? This is the rule. If you don't know anything, then have fun. Anyway, so now I differentiate this one, I keep this one, and therefore I differentiate this thing. So I just write it down over here first. I differentiate the outside first. So I think I left over here. Sorry, because something went wrong, so I need to. Anyway, so half, I bring it down here, and then I differentiate the exterior one, and then I differentiate the inner one. So I have 2r. So half times 2r, I have r. So I have r squared plus h squared minus half. I believe you know what I mean. So I differentiate the outside one, I have this one become minus, and then after which I differentiate the inner one, and that's all. That's the product rule. I mean the chain rule that happens in the in differentiation, right? So and therefore this is the one that I'm talking about, and this is the I don't know what the hell am I talking, because I paused the video for damn long, like 1 hour plus, so I don't know what I'm talking just now. So let's continue. Okay, in fact this is pi r, because I think I just now I didn't write it properly. So I differentiate this term into this two of it, alright, using the product rule that I said earlier, I think. Yeah. Sorry. So now I only differentiate in terms of ds and dr, right? So now I gotta differentiate partial s in terms of partial h. So same thing, but however, there's no h over here. So if I differentiate in terms of partial h, this one becomes 0 plus in this case this term is some constant, because it's in terms of h now, so this is just some arbitrary constant. So I just differentiate the interior one will do. So in order to do that, let me just write it down also, so at least it's pretty much cool, right? So if I were to differentiate, I bring this thing down, so I have half pi r r squared plus h squared minus half, and then I differentiate the inside, which will have 2h over here. So in this case I'll have h pi r, because 2 and half cancel each other, so h pi r r squared plus h squared minus a half. Yes. So for purpose of neatness, I'll just erase the working just now. Alright. And alright. So what I'm gonna do next is okay, so I have partial s and partial r and partial s and partial h. Okay. So in that's the case, then I'm gonna fill this in. Alright, so partial s and partial r is this term over here. So I would have, so I'm simply filling this term into here, so that at least you know what I'm gonna do next. Alright, so I filled it in over here, and then I'll fill it up, this term in terms into here, because that's what we have just done earlier. Okay, and therefore then I can just cancel this working, and we are back to writing down the terms. Now we're gonna elaborate this one. So partial and partial t and partial h and partial t is r and h differentiate in terms of t. So the question itself has already told you that if r and h are each increasing at rate, so this means that r and h are changing in terms of time. Alright, so if they're changing in terms of time, you're talking about these things. So therefore, they individually they are 0.25, and we can just write it down as 0.25, and this is it. We have the terms written down, and therefore we're just filling the blanks now, right? So we're just filling this thing into this dude over here, and I just fill in this thing into the partial r partial t term over here. Hope you get what I mean. And therefore when I fill it in, I have this. Alright, so this, if I were to zoom out a little bit, so this term over here that we have just written over, it's this term. while this term is this term. That is all. I'm just trying to fill it up. So I'm just simply taking all this and then just sub it in over here, and we have all of them over here. So now this comes the somewhat the hairier part, right? Now we're gonna sub in our R and H, where our R is equal to 3, H is equal to 4. Alright, so find the rate of S when R is equal to 3 and H is equal to 4. And therefore when I sub it in, I think we can do together. So it'll be, at least you know what am I doing. So R equals to what? R equals to 3, H equals to 4. So just to recap lah, okay, this 1/4 belongs to this one, okay, and then this whole term belongs to here, and then this term belongs to here, and this term belongs to this one. So I'm just simply subbing it if you still don't know what the hell am I talking. Okay, sorry I didn't explain it explicitly, but yeah. So therefore 1/4 2 pi r, which is we have 6 pi, right? 3 equals r, right? Hope you get what I mean. Plus pi, and then 3 square, which is 9, plus 16 as square root, plus pi 3 pi, and then we have 9 plus 16 minus half square root, plus 1/4 h pi h 4 times r at 3 is equals to 12. Therefore we have 12 pi over here, and then we have 9 plus 16 minus half, right? What I've done just now is simply subbing in r is equals to 3 and h is equals to 4. If you were to do what I've done just now, you should get the same thing as what I've written over here. And therefore when I made it a little slightly neater, I would have I just realized that I didn't put in the square, right, when I differentiate. So this thing should be square, alright, because when I differentiate in terms of r later on, I believe you have already know what I mean, because I think in the earlier part I have do some corrections in the comments. So this should be 9 pi, right? Alright, so I'm just simply so-called summarizing this. So this one, 9 plus 16 is 25. 25 square root is actually 5. So this one, 25 square root, which is negative half, is actually equals to 1 over 5. This is what it means. Alright, so when dealing with this, be very careful of what they are, what this type of things would actually come by. Alright, so I'll not elaborate on this thing on how to simplify them, but at the end of the day you should get 19 over 5 pi is equals to 3.8 pi, and that's the answer. So I'm just conveying the approach and just a little bit on how to differentiate it, so that you can better understand the steps and the hairiest in its hairiest manner way. So I hope that this can be a fairly helpful stuff for you to rely on, and yeah. So along the way, if you don't know what the hell am I talking just now, so I would suggest you just click back and go and watch it out, and it should be fine. But otherwise, if you really don't know the basics, I would still suggest you watch.
This first problem is what we call a case 1 type function.
Okay, so I shall see you there. Next video. Goodbye.